You're watching Impact on BBC World News. The fastest growing black hole has been discovered by scientists. Astronomers led by the Australian National University spotted the supermassive black hole about halfway across the universe. It consumes the equivalent of 1 Earth every second. It weighs the equivalent of 3 billion suns. I'm joined now by Professor Christopher Reynolds in Cambridge. He is an expert on black holes at their Institute of Astronomy. I read it's visible from a back garden, a backyard, but it's only been discovered, and yet it's the biggest one. How did it come about?
Yes, that's right. So this is an incredibly massive black hole, so 3 billion times the mass of the sun, as you mentioned. And to a large extent, it had been previously overlooked because it was so close in the sky to the Milky Way, to sort of the plane of our galaxy. And so that's such a difficult place to sort of find and identify strange objects because there's so many stars there. It had been previously missed.
This is where I get lost in all these figures. So it's so big, it's swallowing up the equivalent of planet Earth every second. It is, 9 billion years old, but the images we get from it are 7 billion years away. Could you explain that one for me?
That's right. So we look at this object using the light it emits, and light travels at a certain speed. So if we look at a star that's, say, 10 light years away, we see the star as it was 10 years ago. But if we look at this object, which is, as you say, about 7 billion light years away, we are seeing it as it was 7 billion years ago. Now that's halfway back towards the Big Bang. So we're actually looking at this object at a much earlier time in the history of the universe. It's still not what we would call the early universe. The early universe is, you have to be looking back, 12 plus billion years for that, but a billion light years. But this is sort of in the Middle Ages of the universe, if you like.
It is incredible. And just looking at some of the graphics that we've been playing whilst we're speaking to you, I mean, this is what we think it is looking like, because presumably, I mean, when you're not seeing movement like that, are you?
No, well, so yes, what we see is really just a point of light. We see this point of light, and we can study it using its spectra. So with telescopes, we can break that light up into its wavelengths, into its different wavelengths, and we can study how much light there is at each wavelength. And from that, we can actually glean a lot of information. It's an analysis of that light that actually lets us measure the mass of the black hole. There's ways that you can take features in the spectrum, so-called emission lines in that spectrum, and measure the mass of the black hole. But we don't see a movie, if you like, of the black hole. It's just too far away. And also, quite frankly, with a black hole that massive, things happen on quite long timescales. It can take many days just to orbit around the black hole once.
Yeah, just briefly, if you would, what does this tell us about how the solar system formed?
Well, yeah, so it doesn't tell us how much.
10 seconds.
Yeah, in 10 seconds. Well, the very origin of these supermassive black holes is a deep mystery. We don't know where these supermassive black holes come from, and so understanding how they grew and then sort of extrapolating that back in time and understanding what the initial seeds were that may have grown up is really a key goal in astronomy. And we know that black holes have a tremendous impact on the galaxies that host them because of the energy they put out. So understanding how black holes grow is really about understanding how galaxies grow. And we live in a galaxy, so understanding ourselves can actually be connected to understanding the galaxy we live in.
Absolutely fascinating. And I knew a professor of astronomy from Cambridge University would be able to do that in about 20 seconds. Thank you very much indeed for joining us.